write the first,
This
yeah, first four elements of the sequence. N plus 1 over 3n minus 1.
Sir, we cannot see your camera.
Oh, no, I'm letting you write the first one down.
Oh, okay.
I'm done writing it. Can you see this?
Now I can. Yes, thank you.
All right.
Okay. All right, so the first one is pretty easy, right? Literally, write the first four. So if I call this a sub n, just to label my stuff, a1 will be 1 plus 1 over 3 times 1 minus 1, right? So that would be 2 over 2, which is 1. A2 will be 2 plus 1 over 3 times 2 minus 1, which will be 3 over 5. A3 be 3 plus 1, 3 times 3 minus 1, which will be 4 over 9 minus 1, 8, 1 half. Finally, fourth one will be 4 plus 1 over 3 times 4 minus 1, which is 5 11ths. So no big deal, number 1, right? I'll put this back in just a moment. So the first one, that's all you do. Second one is second and third are limits. So let's do the second one, I guess. You write the question down really quick. Find the limit of the sequence. A sub n will be equal to 2 plus 5n over 4 plus 9n. Okay. So the limit of a sub n as n goes to infinity going to be the limit as n goes to infinity of 2 plus 5n over 4 plus 9n. So the degrees are the same, right? That'll just be 5 over 9. Nothing crazy. Any questions on number 1 or 2? So you just take the highest degree. If they are the same, you divide by 5 and 9. If you wanted to, yeah, they don't do anything. The next one, if you look at it, it's alternating, right? So it doesn't have a limit because it never stops at a specific point. It's either positive, negative, positive, negative. So the sequence does not have a limit. So it should diverge. Remember, these are still sequences. We haven't got to series yet. Don't mix those up in your head. Number 1, 2, 3, so 4. Is another sequence. By looking at it, can you tell if it converges or diverges? Which one's bigger, the top or the bottom? That has n times 4 to the n, right? So the top's going to grow faster than the bottom. Yeah, I think it's going to be infinite. So technically, even though these are the same, you can technically, what's the word I'm looking for? When we're dealing with infinity, the 1 doesn't matter, right? So these will kind of cancel out. So we left only with the n, which will just keep growing by itself. So these guys will overpower each other, but the n is just solo. So it's going to diverge. So if you take the limit, let's see, what's a good way to explain it? Oh, okay. I see. Example, not number 4, right? Determine. I'm just going to shorten it up, converge, diverge. I'll switch over in just a second. Determine if it converges or diverges. I just realized, and while I was staring at this, that you can separate this into 2 fractions, right? Which will cancel. So that means that a sub n is actually 1/4 to the n plus n. So the limit will clearly be infinite now. Now I can show my work, not just think about it. This goes to 0, becomes infinite. The n just keeps growing. Diverges. So whenever you're dealing with sequences, well, they didn't ask them now. If a limit exists, then it converges to a finite number. So that's all you check. If it doesn't exist or it's infinite, diverges.
Professor.
Yeah.
Is this the exam problems?
This is the review for
The
chapter
review.
9. Yeah.
All right. Yes.
So we finished chapter 9 last time. Okay. And let's move on to series now. So this one right here, what do you think what type of series is this? Can you tell? Did they give you a hint? They ask for a sum.
Power of series?
Which one?
Power of series? No, right? No.
No. So remember, there was only one formula that gave us a sum, right? Do you guys remember? It was like the first thing we did. One of the first things for series. That if it was geometric, then you can find a sum, right? If it converges, and it all depended on the R. Does that sound familiar or no?
Sequence. No.
Just regular geometric. That's what it was.
Okay.
So let's write that one down. Find the sum. So they didn't ask about converges or diverges, but if they ask me to find a sum, then that implies that it must converge. Otherwise, there's no sum. You guys remember the formula for sum? It was like A over 1 minus R or something like that. Actually, I don't remember. I might have to look it up if you guys don't remember. There it is. That was the sum of n equals 0 to infinity of AR to the n is equal to A over 1 minus R. So our A is going to be the 9, right? The R will be 1 over 7, because we can rewrite it as this here. So sum will be 9 over 1 minus 1/7. Excuse me. 1 minus 1/7 would be 6/7. What's 7 times 9? Does that reduce? Yeah, let's say 3 goes into both, right? So how many times is 3 going to 63? 21? That's about it, right? Good as it gets. They didn't ask for convergence or divergence. They just said something. But it is implied that it did converge, right? Because, but what is the requirement for geometric to converge? You guys remember?
Is bigger.
But it depends on the R. I recommend you put all the rules on one page. When I was a tutor, I'd carry note cards around, like all the ratio root tests, like those. Yeah. Eventually, I didn't need them anymore. For a long time, you'd be all right. What is the trig identity, or what is the? It helps. I kept them for years, just little formula sheets, because they always come up again, you know. Yeah. All the way from elementary school. Let's see. Yeah, so convergence was if R is less than 1, by the way. That's it. What number was it? 6. Just take all days looking through them. Okay. If it converges, find its sum. So all they give us is this 1 plus -9 plus -9 squared plus -9 cubed -9 to the 4th. So first is create the series. What is the series? For sure there's a 9 in it, right? But it's not alternating, right? They're all negative. Only weird one is the 1. But I'm sure we could fix that. So I'm thinking there has to be a -9 here, right? So what is the index? Let's start at. Right, clearly this is 1, 2, 3, 4. So what is this first one going to be? Yeah, it has to be 0, right? Because anything to the 0 will give me a 1. That means this has to be the power. That makes sense? And -9 to the 0 will be 1. -9 to the 1 is -9. -9 to the 2 is etc. Once we have it, we can kind of see. See what's going on now, right? So they told us a geometric, so that was nice of them. What is R? In other words, what is the factor they all have in common? Yeah. -9 technically, right? But for it to converge, the absolute value must be less than 1. Is it? Is R? I should put it equals here. Not bad. Right. 9 is not less than 1, correct? Therefore, it diverges. If it diverges, we don't have to find its sum. So since we're in English, right? Since R is greater than absolute value is greater than 1, then the series of A sub n diverges by the geometric test. Any questions on number 7? Is that all right? Number 8 is the same thing, except the R is 1/5, right? Switch over real quick. So this one, it will converge because R is less than 1. Absolute value of R less than 1. So it will have a sum. So we use a formula from number 6. Move on to number 9. So use the nth term test to test for divergence. Or state that the test is inconclusive. Do you guys remember what the nth term test was? Or the divergent test, also known as? Tomorrow, for sure. All you have to do is take the limit of a sub n. That's what nth term test means. You take the sequence part, take a look. So that limit will be 1, right? Since the limit is 1, what does that mean for? Since the limit of the sequence is 1, what does that mean for the series?
The limit is sister not converge.
But if it's not 0,
Sure, that is
so since the limit of a sub n is not equal to 0, then the series diverges. What's it called? The sequence right here converged to 1, right? The series diverges. So whenever the sequence is not 0, you can just stop and say, all right, the series is not convergent. But if the limit is 0, then you got to go through all your tests, pick a better test. That's why whenever you're doing these problems, I recommend take the limit first and see what's going on. Then pick a test that you think is most appropriate. Okay. Yes, cool. Number 9. All right, so that's number 9. 10, it wants to do an integral test. Guess we could do it. Yeah, we'll do 10 in a second. We'll skip 11. Wait a little bit. You guys go on the page or not yet? to determine, so use the integral test to determine whether the series converges or diverges. Sorry, I got distracted. So when we did the integral test, as long as there's a finite area, right, or finite value, then it converges. If the integral turns out to be infinite, then it diverges. It's pretty easy to tell. So what you got to do is change the bounds. So let b go to infinity, integrate from 1 to b of 1 over 2x minus 1. So just change it to x. Use the notation for infinity, like we did in the improper integral section. Remember? 8.8. So that's basically what we're going to do. So integrate this guy here. So let u equal 2x minus 1. du is what, 2? du over 2 is dx. There we go. About to have if you want. That will be, if you want, you put d over u, it's whatever. So we will get the limit as b approaches infinity of 1/2 ln u from 1 to b. Change it back to x and take our limit. So plug in the values, you'll get 1/2 ln of 2b minus 1 minus, this is all in brackets here, 1/2 of ln 2 times 1 minus 1. What do you think this limit is going to be? Like b is going to infinity, right? And infinity is inside the logarithm, so this isn't going to be infinite. This just keeps getting larger and larger. Times 2, I guess. So since the integral diverges, then so does the series by the integral test. there any questions on number 10? All right, you guys going this way? Okay. We'll do uh, 13, I guess. 10, 11, 12, 13. No. Hopefully not too many. I'm tired. Be here till tomorrow. Use the ratio and root test to determine convergence or divergence. Right, so ratio. Oh, I'm sorry, I just said use ratio. I don't know why I put root 2. That's weird. Never said that. So for ratio, we need to pick the a sub n and then add +1 to it for this part right here. 8n plus 1 over n plus 1 . So the limit is going to be What is it over an plus 1 over an? Or an plus 1? Ratio test. Which one's on top? I want to say an. Let me know if you find it. Yeah, an plus 1. Okay. So we just gotta divide these two. And then check if the limit is less than 1. Absolute value. So less than 1. So I'm gonna skip the algebra here. Hope that's cool. Multiply the n factorial over a to the n. Technically still in absolute values, but it doesn't matter. There's no negatives. Do some algebra to simplify this. 8 to the n times 8 over n plus 1 factorial times n factorial. Ah, shoot, I'm supposed to expand this. Expanded to n plus 1 and then n factorial. 8 to the n, so these will cancel, this will cancel, giving us the limit of 8 over n plus 1. That's the limit is going to be 0, right? So the conclusion, so since the limit of an plus 1 over an is equal to 0, which is less than 1, then the series base of n converges. Any questions on 13? Make sense? 14 will be similar. Same with 12. 15 is different. That one's a straight up root test. For the next one, you have to figure out which one grows faster. 15, right? The root test to determine if the series converges or diverges. So for the root test, we take the AN and take a nth root of the whole thing. And then we take a limit. If the limit is less than 1, then we're good. So the limit of the nth root of the nth value of a sub n must be less than 1. So the limit as n approaches infinity of the nth root of ln n over 9n plus 1 to the n is going to be the limit. These n's will cancel, giving me ln of n over 9n plus 1. So what is that limit going to be? Can you tell? Is ln bigger or is n bigger? Which one grows faster? You know his graph, right? See what's going on. ln somewhere here. So ln versus x. See which one's faster. There's ln. There's x. So it looks like the limit's going to go to 0, right? The bottom is faster. The limit will be equal to 0. So since the limit of the nth root of an is less than, is equal to 0, which is less than 1, then the series converges by the root test. That makes sense. No questions on that one? All righty. Let's see, next one's another root test. Okay. This one's a, look, well, you guys look at this one. It's no longer telling you what test to use. What would you use? Well, let's write it down. Where is that? 13, 14, 15. That's the first thing we should try. I gotta hope it's not 0. Okay. The first thing we should try is take the limit of the sequence and see what happens. What is the limit of the sequence? bottom is bigger. Okay. So it's going to be 0. So that tells us nothing. So we need to pick a different test. What tests do we have? Like 20 of them, right? So we got the nth term test, which is what we just tried. Didn't help us. You know, geometric, if it's a geometric, which it's not, right? We have the root and ratio test, which I don't think are good here. Now, the root wouldn't work at all, right? Ratio would probably become very difficult to use. We have the alternating series test. It's not alternating. We have the comparison tests, direct comparison and limit comparison. An integral test. Integral test, though, is
Separation test,
what's that?
portion? No.
You can always do integral if it's an easy integral. This doesn't look like it would be. So you want to stay away from that idea. Only do integral if you have no choice or you think the integral is easy. I think we should do a comparison. Remember when we need to choose the BN? Remember that? A while ago. So we would write down the highest powers and say, well, you know what? 6n squared over n cubed will be the comparison, which would be 6 over n. Which one would you say is bigger, this one or that one? This one, the BN or the AN?
Yeah.
This one has a 6n, n cubed plus 6n on the bottom, right? So this one's going to be smaller. This the only thing this is missing is a +2, so the top doesn't really make a big difference. This is making the biggest difference. If we're not sure and we can't prove it or tell, we can always do a limit comparison test. See what happens. So let's do that one because it looks kind of ugly. But the limit comparison said that if you divide them, which is So divide A and B in. So that would be the limit of 6n squared plus 2 over n cubed plus 6n plus 7 times n over 6 that will be the limit of 6n cubed plus 2n over 6n cubed plus 36n plus 42. Right? What is that limit? They're to the same degree, right? So what does this limit comparison test say? If the limit is equal to 1,
Convergence.
both converge and diverge, or I forgot what it said.
Spherical visual test, limit 0 shorter than an.
Well, it's a direct one. The word's the limit comparison. The one I think after that. They both diverge or converge, or what does it say?
Converge or diverge.
Okay, so if the limit is finite, right, then both converge or diverge. So wait, what does Bn do? Okay,
Converge.
what type of series is this? The P series, right? Do you remember the P series rules? All right, so let's put it all together, right? So since the limit of an over bn is equal to 1, then both series converge or diverge. Since bn is a divergent P series because P is equal to 1, then series AN also diverges. by the limit comparison test. So if you use the limit comparison, then you need to know what the other one is doing. So if you choose it at the end, you have no idea what it does, you get a limit, then you don't know what the original does. So it's a waste of time. If you use direct, then you need to know which one's bigger or smaller. So if you can't figure out which is bigger or smaller, then to go to the limit. Then you need to figure out what the other one's doing at the end. Okay. All right, the next 4 are all power series type. Number 16, all the answers for radius, so you don't have to test. 16 and 17, you don't need to test the endpoints. 18, you have to find the interval of convergence, which means you have to test the endpoints. Okay. So let's do the one with the endpoint. Actually, let me see here. No, these may take forever. I think we'll look at the schedule. Maybe we can stop here. This is a lot of stuff. One sec. I know some of you are brain dead already. Might throw some of these out. Okay, yeah, so we'll review some more on Wednesday. We'll stop here. I don't know yet. I might just put a few problems from the final or figure that out later. Need to decide if chapter 10 stuff. Might pick a couple, but not test you on it. So might do that. But anyway, focus on chapter 9 first.
So the chemical, right?